Hello everyone. I'm just gonna wait until somebody comes over here and type something. Um, okay. In lieu of people not coming, I think Enrique and I think Gayatri said that they wanted me to work out a couple problems for them in the homework. This was on page 572. And that was number 4. This is on the guided practice, by the way. So it says that Logan is flying a kite that is made up of 3 similar rectangles. The size of all 3 rectangles are in the ratio 1 to 2 to 3. If the area of the smallest rectangle is 72 square inches, what are the areas of the other 2 rectangles? Okay, so here are the ratios. Well, I mean, if it helps you out, you can draw 3 rectangles. 1, 2, and 3. 3 rectangles, right? And the ratios are 1 to 2 to 3. Okay? And it says the area of the small rectangle, the area of this one, is 72. And that's in square inches squared, same thing. Okay, so if you remember the how you find area of similar rectangles is you have to take the area of one and you multiply it by the scale factor. Maybe I'll write this out for people who don't have volume for some reason. Scale factor. Okay, that will give you the area of the bigger one. So let's just say, so the ratio is 1 to 2, right? So that tells you the scale factor already. Okay. Oh, I'm sorry. This is going to be a scale factor squared. Sorry about that. Okay. So this tells you the scale factor between this one, this rectangle, and this rectangle. So it's 1 to 2. That's the relationship, right? So the scale factor is 1 to 2. We know that this is going to be 2 squared because going from this rectangle to this rectangle, you have a scale factor of 2. So you take the area, 72, and you multiply it by 2 squared. That should give you, let's see, I don't know what this is. 72 times 4, 8. So that should give you, for this one, so this area here is 72 inches squared. This will be 288 inches squared. Now the thing that people get confused about is this one. What's the relationship between these two? Well, you don't need to know that. You don't need to know that because you can just use this. So going from the first rectangle to the the third rectangle, it's a ratio between a ratio of 1 to 3, right? 1 to 3. So that is a scale factor of 3. So again, it's the area times the scale factor squared. So the area of the small one is still going to be 72. I'm going to multiply that by 3 because going from 1 to 3 is 3 squared. Okay, so that's going to be 72 times 9. That's 18. And that's going to be 64. So the area of this is going to be 648 inches squared. And that's the answer for number 4 on page 572. Oh, hi, Gayatri. Mr. Nguyen, on the homework yesterday, I needed help with the last problem on lesson 7. What was the homework yesterday? Was it the book work? Lesson 7. Which one was that? Can you be a little bit more specific? Is it in the book or was it in the what should we call it? A worksheet? Because I don't remember. Maybe Gayatri stepped away. Let's see. Um, okay, 470. That was no, that's March. I think Gayatri stepped away or something. Do today practice worksheet. Well, the problem, Gayatri, is that it's double-sided, and this is lesson 7. Okay, so is that the one with the flower garden? A rectangular shape. Let me put this out here. Okay. I don't know if you can still see me. Okay, so this Gayatri wants me to work out number. I'm presuming number 8. This is lesson. What's this? Lesson 7 from the worksheet from yesterday's homework, which is 325, and that's number 8. Is that right? I don't know. I don't even know if Gayatri's still there. But anyway, I'm gonna work it out anyway. Okay, it says a rectangular shaped flower garden has a length of 5 yards. It's always useful to draw pictures for this. So I'm just gonna draw a rectangle. I want to double check to see if you see this. Hey, Gayatri, there you are. Okay, so is this the right problem? Yeah. Okay. Yeah. Okay. So a rectangular shaped flower garden has a length of 5 yards, um, 5 yards, and an area of 15 square yards. Well, this has to be 5 then, and this has to be 3 for it to be 15. But anyway, a neighbor's flower garden is similar and has a length of 7 yards. Okay, forgive the drawing over here. 7 yards. Okay, so this is yards, yards. Okay. What is the area of the neighbor's flower garden? Round your answer to the nearest whole number. Okay, so scale factor. How do you go from this to this? Remember, if you go from this to this, you need to have, so this is what you're looking for, area. You need to have a ratio that's larger than 1, because when we talk about scale factor, if it's greater than 1, it's going to enlarge. If it's less than 1, it's going to contract, or I forget the official term, it's going to shrink. Okay, so here is your scale factor. 7 to 5, because that's the ratio. Okay. It says round your answer to the nearest whole number. I'm not going to do that right now. Remember, going from area to area, you have the area. I want to double check if you guys can see this. Okay, you can still see this. Okay. All right. So area of 1, and you multiply that by the scale factor. In this case, that's going to be 7/5 squared. So the area is 15. The scale factor for this is 7/5 squared. Okay. So what you have is 15 times 49 over 25. Okay. Then you can cross cancel. This becomes 3. This becomes 5. So you just multiply this across. 49 times 3 gives you 147 over 5. And it asks you to give your answer to the nearest whole number. I guess we just divide it out. Why not? Because I think Gayatri is the only one here. So okay, so this is 2, 10, 4, 7. This becomes 9, 45, 2 decimal point, 4. So it should be 29.4. Let me double check. Let's see if that's the right answer. Is this? Okay, course 2. Sorry, give me a moment here. I'm going to find the worksheet with the answer key and double check the answer. And this is that one. Yeah, okay, so that's right. That's 29. Yeah, that's correct. It says round the answer to the nearest whole number, so that's 29, but whatever. I think that's right. Okay, so there you go. That's your area. So the area is going to be 29, I guess, whole number yard square. Okay. Any other questions? Oh, Gayatri, if you don't have a question, I'm going to go to Enrique's question from yesterday. He said, which problem was it? Number 6 on page 573. It's on page 573, and that's number 6. Okay, so the problem says that Craig is making a model version of his neighborhood that uses model trains. The ratio of the model train to the actual train is 1 to 64. His neighborhood covers an area of 200,704 feet. So this is the actual neighborhood. That's going to be 2,704 square feet. What would be the area of the model neighborhood? Okay, so remember when we know the scale factor for this, okay? The scale factor, because it's 1 to 64, it makes it really easy. So that makes the scale factor 64, okay? So it's asking what is the area of the model, right? So remember, it's going to be the area of the model times the scale factor squared is equal to the larger area, the actual area, right? So we know what the actual area is. it's going to be this 200,704 feet squared. And we know what the scale factor is. So again, I'm just going to put A for area. We know what the scale factor for this is. It's going to be 64 squared is equal to 200,704. Okay, so 64 squared, I don't know what that is. I'm going to do a little multiplication on the side. 16, 24, 25, 0, and 6, 5, 2. Why did I say 25? Ah, jeez, I messed that up. 16, yeah, it is 24. 25, and this is going to be 24. Messed that one up. 24, this is 36, 38. Add this together, 6, 9. It's going to be that. Okay, so again, you have area times 4,906. 4,096 is equal to this. And you just find it by dividing this. And I think this should come out to 49, exactly 49, if I'm not mistaken. So that would be your answer. Okay, so nobody has shown up except for Gayatri. I'm gonna keep a record of this. So if nobody pops up in the next minute or so, we're gonna call it a day. Okay, so again, I'm going to post this on the website, the Google Classroom. So if you want to see these problems worked out, they'll be there. Okay, and I think that's 17 minutes into this, and I think I'm gonna end the stream. Okay, have a good day, y'all. Bye.